Alright, I'm about to continue working on the Atari Soccer PC board, and the pinout is not been captured online that I can find. So I'm doing it myself here. So I'm taking a photo of this. If anyone needs it, you can print it out or duplicate it, whatever. But that seems to be the accurate pinout for the Atari Soccer PC board. So I pulled out my retro chip tester to test that 7496 to make sure it was bad. So I've got him plugged in there, and I've got it set up for 7496. So it is bad. It is testing bad. So confirmed in the tester, confirmed by the scope, and confirmed by the logic probe. So I'll get that reset fixed as soon as the chip comes in. It'll be a while because I'm ordering from China. Okay, so with my jumper installed, I've got the reset on the processor in the proper state. So the processor should be able to run. Now, these schematics are crap. I printed them from offline and they're fuzzy, but they're better than nothing. Pin 4 is an interrupt acknowledge. This pin, when I probe it, is always low. So that's why the processor's not doing anything. It's always an interrupt. So you can see there, pin 4 is always low. Processor's an interrupt constantly. Now, why is that? Well, if you look at this stuff, we've got a 74 D latch, or a D flip-flop, and we've got a 7402. Not sure, I can't read that. The chip at E9. Chip at E9. 7402. Right there. That gate is not letting the interrupt signal pass through, but the gate's not the problem. The problem is interrupt acknowledge signal is not happening. We've got two pull-ups, those are working. We've got a clock signal that's buffered read-write, I think. And we have complemented Q and Q bar outputs. So this device is working, it's just not receiving the clear signal to generate the pulse that can go through there. Interrupt acknowledge. Comes from this circuit. Actually, it doesn't come from this circuit, but the output signal is what is part of what is used to generate the interrupt acknowledge. And that signal is not changing. So the chip at C5 right here can have activity on the inputs. This is a 4 to 10 decoder, basically. So there's no activity on it now, but if I hit the reset button enough times, it will start working. So we've got activity on those input pins now. Oh, you can't see it. Activity on the pin, activity on the pin, activity on the pin. No activity here. It's always high. So this chip, I think I'm going to want to replace to see if it fixes the problem. This is a 7442. It's a BDC decoder. So I guess what I'm going to do is go ahead and leave the wiring and junk still hooked up, this mess that I have, and try to replace just this, and then I'll tack on those wires to see if that gets it working. I've replaced that chip, that 7442, and I've rerouted the wires that went to it. I found a couple of appropriate places to connect those wires. Still getting the same results. Still not working. So this chip is probably fine. I'm wondering if I don't have a trace problem or some corrosion, or this chip has lost part of its program or something. I don't know. But that's it for tonight. It's getting late and I'm not wanting to look at this anymore tonight. But yeah, still not getting the output signal that I need from that chip. Well, today's the next day, and replacing the 7442 decoder didn't fix my problem. So I just turned this on. I've hit the reset switch. It does try to do something. It looks like it tries to run the self-test, but then it doesn't finish. Since replacing this chip didn't fix it, I think I'm going to go ahead and take all this garbage off. And I've built up a board to try to get this to replace the ROM and all the extra decoding crap I added, and put it in where this microprocessor goes, to see if that's going to work. I don't know why it's not running, and I expect that it won't run with this, even if it's correct, because it's not running with this. Of course, the ROM might be bad. Not sure why it would be, but maybe it is. So anyway, that's what I'm going to do. I'm going to reverse all this, take all this garbage off, clean it up a little bit, and then I'm going to try this board that I've just built up. Okay, so I got all this garbage removed, and I got traces cleaned up. I got the new board installed, and I've got it in self-test, and here's what I'm getting now. I'm getting a bad ROM error and a RAM OK. So I think my problem may have been the whole time this ROM is bad. So I'm going to extract the ROM, check the codes, reprogram it as needed, and then I will try again. But this is great. This means the addressed encoding is most likely correct on my modified board, and I simply just have the wrong codes in that sucker. So let me go check that out, and I'll be back. Okay, so I got another ROM, and I downloaded all the ROM images and built up a new ROM, and I compared the old ROM with the new code that I created from the downloaded ROM or PROM codes. The PROM data that I could find online did not give me was not in the form of the 4 large ROMs. It was in the form of the 16 small PROMs, and each PROM is 4 bits. You got a low and a high nibble on those, and those get combined to form a byte. So I took the 16 codes and I wrote a program to merge the bytes together, and then I did some concatenating to generate the 4 ROMs, and then I took the 4 ROMs to create the big ROM. And now this is what I'm getting. It's working better, but I'm still getting a bad ROM, so maybe I combined the data wrong. I'll have to double check my work on that. It tries to play before the other one didn't even try. And since I don't have the reset chip that I need, I'm having to manually do the resets to run the self-test. So that's where we are. It's looking better, but still have a ROM code. So let me go and study what I did. Maybe I created this wrong. So I downloaded the ROMs from a different site, and I compared them with the first site, and they matched. So I went through the rigmarole again and regenerated the codes, and this time it's working. ROM OK, RAM OK. Passes self-test. And the game is playing. Hell yeah. Okay, so all of this was for 2 problems. First of all, we had the reset problem, which kept the board from even trying to run. And then when it did try to run, the ROM codes were bad. I don't know how that happened. I don't know why that happened. It had been sitting around for years. I don't know. But got the this board here originally was for an Atari football, and these are all very similar. Atari football, Atari baseball, 4-player football. They all very similar in how they address the ROM. Now this one uses lower address rates. It's 200 through 3FF. That's what the range is for this one. On the football, it's 600 through 78 or 7FFF, I think. Something like that. Anyway, different, but I was able to modify this board slightly to get it to work for the different address range. I guess the next thing for this board will be to hook up some connectors for plugging in a trackball to test each of the 4 players. And well, that's basically it for this video, though. I just wanted to get this running with the you know, with the proper, with it all cleaned up. I just did not like that spider of wires going everywhere and that hacked up solder job with the socket. Anyway, that's it for this one. Thanks for watching, guys.